Hello, this is Catalytics and welcome to today's session. In today's video, we are going to look at a very interesting statistical analysis that can relate to clinical situation. So here we have a data set of patients and we have variables such as their sociodemographic characteristics and some of their biochemical markers, including some vitals. But our focus is going to be on how or whether there's an association or relationship between the systolic blood pressure and some of the demographic characteristics like age, sex, marital status, occupation, and then educational status. So we are going to see how these variables affect one's systolic blood pressure. And also we are going to explore whether there is an interaction between sex and marital status. And then we'll also see how we can use the STATA platform to make interpretations of such interactions very meaningful. So if you watch this video right to the very end, you'll be able to know how to fit a linear regression and also know how to run an interaction term and also interpret it given the plots. So without wasting my time, let's go. Let's delve in and start our analysis. So basically, that is our aim, to see whether systolic blood pressure is affected by some demographic factors. And then we also want to see if there's an interaction between sex and marital status. So that is our goal. So now let's translate it into statistics. So to do that, we do a regress. So it's a linear regression. So we type reg or regress. Then we go on to type our dependent variable, which is what? Systolic blood pressure over here. Then now we add our outcome, our exposure variable or our independent variables. So, so we have age. Now, age is a continuous variable, so or it's a quantitative variable and it's not categorical. So we'll not add any suffix to it. Now, but when we come to sex, sex is a categorical variable, so we add I dot. The same applies to marital status. So we put I dot marital status. Then occupation, I dot occupation, and then educational status. Sorry. So I dot occupation, and then I dot educational status. Then our interaction term, to fit an interaction, would bring our asterisk between marital status and sex. So it's a hash. So we put a hash between sex and marital status. So this is the interaction term we are fitting. So we want to see how age, sex, marital status, occupation, educational status, and then the interaction between sex and marital status have on systolic blood pressure. So that is the meaning of the code. So we press OK, and then we allow STATA to give us the output. So these are mathematical computations that STATA does at the back end and gives us an output. So the p-value here is statistically significant. The R-square tells us about 90.6% of the time these variables are able to predict systolic blood pressure. The coefficients are given here, but our focus here is going to be on the interaction term. How are we able to make meaning of the interaction between marital status and sex given systolic blood pressure of these patients? So to do that, we'll go a step further by typing margins. So margins, then our interaction term will come, which is interaction between sex and marital status. Once that is done, we click on enter and we see it gives us a linear prediction or predict margins. So these are predictions of the systolic blood pressure regarding the combinations of the pairs. So single male, married male, widowed male, and so on and so forth. Now, to make it easier for us to interpret, we'll do a margins plot. Just to give us a a pictorial illustration of these values, so as we can be able to tell how marital status and sex are interacting in terms of SVP. So we wait a while for that to be good. So we have our margin plots. So it takes predictive margins for sex, marital status, interaction with 95% confidence intervals. So these are the linear predictions, and then the legend. So the blue one is red, is single, and this color is marital status. This one is widowed, and yellow or orange is divorced. So now let's look at how they interplay here. Now, when you look at those who are single, which is the blue, we realize that males who are single have a lower systolic blood pressure compared to females who are single. Now, when we go to a step further to the married category, you realize that the systolic blood pressure of males and females seems to normalize. So what does it tell you? When a man was single, his systolic blood pressure was lower than a female who is also single. But when they get married, their systolic blood pressure seems to equalize. Now, when there is a divorce, what happens? You realize that whilst the female systolic blood pressure seems to be the same, that of the male increases. And it gets worse when there's when a male becomes a widow or is a widower. So you realize that the systolic blood pressure is higher among those who are male compared to those who are female. So being divorced, married, or widowed relatively has little effect on the female compared to the male. So this is how sex and marital status seem to interact with regard to systolic blood pressure. So basically, this is a concept of running interaction term in STATA. If you find it useful, you may want to apply the concept to any other data set you have. We encourage you to like the video. We encourage you to share. If this is your first time of watching our videos, we encourage you to subscribe to the channel and turn on the post notification bell so you are always notified whenever a new video is released. If you're a returning subscriber, our hearts and mind goes out to you for always making time to learn from us. Until we meet again on our next one, this is Capabilitics, and it's a bye.